In this lecture, let's look at this example of transformations of functions. So in figure, it shows the graph of f of x equals to 3 plus 2x minus x squared. And we are going to find the equations and graphs for each of the given transformations. There are also 5 points that are given on the graph. So on the graph of the transformation functions, we also want to mark the new coordinates. You can pause the video here and try to do the example by yourself. In part A, we have the following 4 transformations: f of x plus 3, f of x minus 3, f of x plus 3, and f of x minus 3. By just looking at the functions, we can already tell that they are translations vertically and horizontally. The first one should be a translation vertically by a unit of 3 upward, and the second one is vertically by unit of 3 downward. And the third one, we have a horizontal translation moving to the left by unit of 3. And the last one is a translation horizontally to the right by unit of 3. Now let's find the equation of each of the functions. The first one, f of x plus 3. f of x is 3 plus 2x minus x squared. And we add 3. So the function is 6 plus 2x minus x squared. And if we substitute the 5 points given in the problem, you'll find that their y values all move up by 5 units. Let's take when x equals to 1 as an example. The original graph has point 1 and 4. But if you substitute x equals to 1 into our new function, you'll find the new coordinates as 1 and 7. You can do that for the other 4 points as well. How about the second transformation? So we minus 3 to the function. f of x is 3 plus 2x minus x squared. Then we do minus 3. So we get 2x minus x squared. So if you substitute the 5 points, you'll find that the y values, they all move downward by 3 units. And let's take the highest point as an example again. So the original point was 1 and 4. And if you substitute x equals to 1 into the function, you'll get 2 minus 1, which is 1. So the new point will be 1 and 1. How about the third transformation? We have f of x plus 3. So instead of x, we are going to substitute by x plus 3. And we get 3 plus 2 times x plus 3, then minus x plus 3 squared. You expand everything and you'll get negative 4x minus x squared. And on the graph, it is a horizontal translation to the left. And the highest point, 1 and 4, is now negative 2 and 4. How about the last transformation? So instead of x, we are going to substitute for x minus 3. We get 3 plus 2 times x minus 3, then minus x minus 3 squared. And we get negative 12 plus 8x minus x squared. And on the graph, it is a horizontal translation, rightward by 3 units. So the point 1 and 4 is now 4 and 4. And in part B, we have the following 4 transformations: 2 times f of x, half times f of x, f of 2x, and f of half x. So by looking at the functions, we see that they are stretching and compression. The first 2, they are vertical stretching and compression, and the lower 2, they are horizontal compression and stretching. Let's find the equations of the functions. The first one is 2f of x. So 2 times the function, 3 plus 2x minus x squared, which equals to 6 plus 4x minus 2x squared. And from the graph, we see that they are vertical expansion. When y is positive, it's double. It moves upward. And when the y values are negative, they move downward, and the values double. How about the second function, half of f of x? So, half times the function, 3 plus 2x minus x squared. We get 3 over 2 plus x and minus half of x squared. And if we look at the graph, we'll see that it's a vertical compression. So when the y values are positive, then they move downward, and the y values is half. If the y values were negative, then they move upward, and the magnitude is also half. How about the third transformation, f of 2x? So we replace x by 2x. We get 3 plus 2 times 2x, then minus 2x squared, which equals 3 plus 4x minus 4x squared. If we look at the graph, we see that it is a horizontal compression. Everything is compressed inward. How about the last one? Last one is f of half times x. So we replace x by half of x. We get 3 plus 2 times half of x, then minus half of x squared, which equals 3 plus x, then minus a quarter of x squared. And let's look at the graph. We see that it is a horizontal expansion. So the y values remain, however the x-axis get an expansion. Now look at the last part. Here we have two other transformations, negative of f of x and f of negative x. So by looking at the functions, we know that this type of transformation is reflection. The first one is a reflection about the x-axis, and the second one is a reflection about the y-axis. Now let's find the equation for the functions. The first one, we had a negative sign in front, so negative of 3 plus 2x minus x squared, which equals negative 3 minus 2x plus x squared. So if you look at the graph, the original graph was an inverse U shape, but now we have a positive x squared, so the quadratic is now facing upward. We have a reflection about the x-axis. How about the second one, f of negative x? So we replace the x by negative x. We have 3 plus 2 times negative x, then minus negative x squared, which is 3 minus 2x minus x squared. And if we look at the graph, although it looks very similar to a horizontal translation, because a quadratic function is symmetry about its pivot point, but this is also a reflection about the y-axis. And that is the end of the lecture. In the next lecture, let's look at an example of odd and even functions.